So there are some reminders. Okay, so remember paper 3, if not changed, it's still 15 marks. In the SPM will be 15 marks only, 15 marks. So 15. Okay, so there are some reminders here. Okay, as you can see, you can write in bilingual, it's okay. Bilingual answer. Mixed language, actually is accepted. In paper 2, it's also the same. Then grammatical errors are ignored also. Okay, we don't penalize the spelling, the past tense, present tense, okay, active or passive is okay. Okay, but the wrong spelling, the technical terms must be correct. This one very important. The technical terms, for example, alkane must be correct. Covalent spelling must be correct. If wrong, then will be penalized. Okay, chlorine atoms, all this must be correct. Cannot be chloride atoms. Then avoid, don't use abbreviation. Abbreviation means short form. For example, ECS is a short form for electrochemical series. Okay, and other short forms, don't use the short form. Okay, you can use the formula. Formula can, but short form don't use. Okay, then observation. Okay, observation is very important in the paper 3. So most observation is drawn from the side. Means what you can see. Okay, now we look into some example here. Okay, incorrect or rejected one. Let's say you write clear solution, which is wrong. Okay, clear solution wrong. Then the correct one should be colorless. Colorless solution. Okay, and number 2, observation. Directly write the name of the gas. You write hydrogen gas release as your observation is wrong. Okay, the correct one should be what? Colorless bubble gas release. Okay, colorless bubble gas. So as an observation, you just can see the colors only, right? If no color, means colorless. Okay, this one, next one is also the same. Copper is formed also. Cannot give the name for the chemicals as observation. So what can you see is a brown solid. Okay, then this one actually becomes the inference. This is the inference. Okay, then this one also the same. Okay, bromine decolorize. Okay, what is wrong here is initial color need to be mentioned. Initial, then final. Brown bromine decolorize or turns colorless. Okay, this one as the observation. Any question for this? So normally it's 2 marks now. 2 marks. Okay, 2 marks for the observation. Anything you want to ask? So we normally focus with the colors. Okay. Then after that is the inference. Okay. Inference refer to the, let's say this is observation. The inference colorless gas. So you just mention what is the gas. There is a hydrogen gas. Brown solid is formed. So what is that? Is the copper. So this one actually is the inference. Okay, inference. Okay, inference. Okay, so if you are drawing the graph, okay, this one, you have to label the y and x axis, y axis, x axis correctly. Okay, then unit must be labeled correctly. Then shape must be correct, whether it's curve or line. Then size of the graph must be more than 50%. Then scale must be uniform. Then all points must be transferred correctly. Semua. Okay. So this one, graph maybe 3, maybe 4. Okay, depends to the questions. Okay, next. For example, variables. Okay. You need to mention the step the volume of the liquid and the mass of the solid. Okay. So don't use amount, don't use quantity. Okay, these two is not accepted. Don't use amount, don't use quantity. Okay, the correct one should be what? So these two are wrong now. Okay, wrong. The correct one should be what? Volume and concentration, okay, of hydrochloric acid. Okay, right? Okay, next is the accuracy. Yeah? Accuracy refer to what? Refer to decimal place. Okay, so it depends to the type of the calibration of the instrument used. What is that means? Okay, so you need to put decimal place. How many decimal place? 1 decimal, 2 decimal places. So how to determine? Okay, we look into example. Okay, never mind. This time, leak already. The question asks, we don't take any measurement. Means no data. Okay, so never mind. Okay, so I give you another example. Okay, operational definition. Let's say, okay, how to write the operational definition? Let me see. Okay. Let's see this question. Okay, you are given all these things. Example. Example. So you are given, okay, let's say you are given the list. You tick first you check whether it's provided or not. Okay. Then so you are required so you are required to conduct an experiment to study the change of the chemical properties of oxide elements across the period 3. Okay. So plan your experiment by using the apparatus and materials provided in table 1. Okay. Then your procedure should include what method to handle the variables. Okay. So you are given, so next week, okay, I told you in the class already. Next week, I will ask you to write something like this. Okay. So it'll be 2 or 3 marks. Okay. Okay, so this one you can refer to the experiment. Okay, normally how to write the correct procedure. Okay, normally you need to include okay. You need to put what? Okay. You need to include what? Okay, so A plus M plus C. Okay, AMC. Yeah? A stands for what? Action. M stands for what? Materials. Okay, C stands for what? Any containers. Okay. So AMC. So remember, normally your steps must include all these things. Okay. So action. Okay. So for example, this experiment. Okay. So first action. Okay. So action normally you can use the word like put. Okay. For example, okay, put. Okay, measure. Okay, add. Okay. Clean. Okay, and so on. All the action. Okay, materials. So materials you can see from the listed here. So you can see what you want to mention. Okay. So let's say materials here is if it is solid. Okay. So mention the mass. Okay. For example, okay, 2 grams of what? Okay, X. Okay. If solution, acid, let's say 2 cubic centimeter of volume. Normally we put 1 mole per cubic decimeter of hydrochloric acid, for example. Okay, so volume This one is concentration.
Teacher,
Hmm.
how do we know the volume and the concentration?
Okay. So concentration, okay, normally we will fix, I will suggest you to fix it to, actually is 0.1 to 2 lah. So every time you put 1 concentration is safer lah. Then this volume is depends to the C container you use. Okay. So let's say container later is the test tubes. Okay. Test tubes, huh? Test tubes maximum you can put is 10 cubic centimeter only. Maximum. So your volume mentioned here must be logic lah. Cannot be put or measure 20 cubic centimeter and then put into acid, put into the test tube, then overflow already. So meaning that your volume is wrong. Understand? Okay. So let's say if test tubes maximum is 10, right? So normally we will use 1 to 2 cubic centimeter only. But if let's say beaker it has many sizes. So beaker can be more volume, like say 10 to 50 cubic centimeter is okay. Okay. Then measuring cylinder also bigger. So depends to the container you use. Okay, for your experiment. So don't worry here. Let's say next week you'll be given, let's say you are given the test tubes, right? So test tube, and then you are given the measuring cylinder, right? So roughly you would adjust. So this one, I told you already, this one maximum is 10. So meaning that later on, your, let's say here, so your acid, right? Nitric acid, total is 50, right? Cubic centimeter. So concentration is mentioned already, right? So roughly, let's say you need to do how many times? 1, 2, 3. So 3 times, right? So 50. So meaning that test tubes maximum 10 times. Okay, so meaning that you can put 2 cubic centimeter each time for the acid. Then sodium hydroxide also the same, right? Okay, so as long as test tubes, then you can put 2 is safer, or 5. Maximum is 5, 2 to 5 actually. Okay, but late if in the exam, maximum the container given you is the beaker, then the volume is different lah. Let's say 100 given to you, then you can adjust again. But for beaker is it can be bigger than 2. You can put 10, 20, 50. It's okay. Depends to the apparatus. Any question? Anything you want to ask? Okay. Then you can refer to all the experiment that we have done. Oh, okay. I don't tell you which one, but it's very simple one. Very simple one. Okay. Then basically the last 2 steps. Last 2 steps. Okay. Remember, you must record the observation. Okay. Record the observation. Then if you can here repeat the experiment. Okay. Repeat the experiment using what to replace? Okay, what? Okay, like this. So these 2 steps basically you need to put for all the steps. Okay. So far, previous years don't have this in the SPM So, but we don't know this year, so we just get ready now. Okay. Then construct a table to record. For example, record the solubility, right? So use your ruler. Okay, now I use a freehand. It's not advisable Okay. So let's say what is a substance, right? Okay, substance. Okay, then solubility. Now solubility in acid, right? Another one is solubility in alkali. Okay, so now you have how many? 3, right? Aluminium oxide, magnesium oxide, and silicon oxide. So record down. No? Okay, aluminium oxide. Okay, then what else? Magnesium oxide. Okay, another one is silicon oxide. Okay, like this. Okay, then aluminium oxide soluble in hydrochloric acid or not? Okay, you test. Okay, see whether it's soluble or not. Yes, it's soluble. Okay, this one also soluble. Magnesium oxide, this one soluble in acid lah, because it's basic one, right? This one is insoluble. Okay, then silicon oxide, this one is insoluble. This one is soluble. So you record now like this. Under record in the table. Okay, or not? Must be inside the table. No table, no marks. 0 mark. Okay, then explain your observation. Explain your observation. This one more to theoretical. It's okay. Then write down the chemical equation. If have, you write down. Okay. Now relationship between the size of the aluminum oxide and the time taken for the neutralization reaction to occur. Okay, this one more to the this one is related to the rate of reaction. Chapter 7 we haven't discussed yet. Okay, now okay, next is a classification. Okay, if classify, okay, kelas kan you are given. So how to classify into acidic oxide and basic oxide. Okay, so if classify, we will make a table like this. Okay, then acidic oxide. Okay, this one, another one is basic oxide. Okay, so you put in, you try to class. So sodium oxide, sulfur dioxide, okay, nitrogen dioxide, calcium oxide. So which one is acidic? Acidic is this one, sulfur dioxide. Okay, sulfur dioxide and nitrogen dioxide. Okay, you list out like this. Then this one sodium oxide. Okay, another one is calcium oxide. Okay, so you get all correct. So we 2 marks. So classify, normally we put you a table like this. Okay. Okay, prediction, possible. Change in the chemical properties. Okay. So period 2, same as period 3. Okay, basic 2, amphoteric 2, acidic, right? Okay, it'll be the same. Okay. Now we look at another one is okay. This one is under neutralization. It's okay. Okay, here. Operational definition. Okay, operational definition. Okay. So operational definition, you just need to mention 2 things. Okay. What you do, and another one is what you observe. Okay, what you observe. I'll give an example later. Okay, what you do and what you observe. Okay, now I use one example in your notes. Okay. Okay, we look at this example. Although we haven't do this experiment, or we try to do others. Let's say chapter 4, we pick one. Okay, let's say here. Okay, we use this example. Okay. Group 1 metals react we put into the water, right? Okay. So you see here, just now, okay, the procedure, you can have a look here. Normally it's AMC lah, but there are sometimes no need less on 1 or 2. Okay, now observation here is here, lithium moves slowly. Okay, lithium moves slowly. Okay, so inference is what? Lithium is least reactive. Okay, less reactive. Then colorless solution turns the red litmus paper to blue. Okay, this one also one observation. So meaning that this is alkaline solution as an inference. Okay, huh? Now, operational definition. Okay, let's say what is the operational definition for reactivity. Okay, reactivity of group 1, for example. Group 1. Okay. If reactivity of group 1 for theoretical is the ability if it can release valence electrons easier, then it is more reactive, right? Okay, correct, not theoretical. But if you write in the paper 3 operational definition for the theoretical definition, then will be 0 mark. So reactivity here for operational definition. Okay, operational definition. Okay, operational definition is you need to mention 2 things. Just now I mentioned what you do and what you observe. Okay, so here reactivity, how do you know it is a reactive matter in the experiment class? How do you know? Okay, what you do, okay, what you do in this experiment, you put the metals, right? Okay, so what you do, so do, okay, so put, okay, metal into where? Into water. Okay, so this is what you do, right? Okay, what you observe to determine it is a reactive. How do you know it's a reactive matter? Okay.
The metal react.
This one. React. If you write react, you cannot see, right? But you can observe something that shows it is reactive. How do you observe it? You can refer to your observation here. So if it move very quickly, very quickly, or it burns up. Let's say in the following one, this one is burned vigorously, right? So it is a reactive metal. But this one under this experiment is the movement, right? It move very quickly on the water surface. Okay, so this is your observation on the water surface. Okay, the metal moves very quickly or rapidly now. Very quickly. We follow this one on the surface of water. H2O. On the surface of water. Okay, is more reactive metal. So what you do and what you observe. Okay. So when you write your operational definition, okay, you just focus to these two things. You can write in a long sentence, is okay. You want to explain more in what you do, okay. You can write in details also can, that doesn't matter. Okay. Then what you observe, you can write more observation. As long as all are related one, no problem. Okay. The more you write, then it will be more chance for you to get the full marks for the operational definition. Okay. Another one is acid. Okay, acid. For example, give the operational definition for acid. Okay. What is an acid? Okay. If theoretical, acid is a substance okay, ionized in water okay, to produce hydrogen ions, right? Okay. To produce the hydrogen ions. Okay. Then class. For this substance ionized in water, can you observe or not? You cannot see it ionized. Can you see the observation or not? Cannot see. Cannot see the hydrogen ions, right? Okay. So this one cannot be operational definition. This one under paper 2, yes, correct. But paper 3, this one confirm is wrong. Okay, so then how are you going to define it operationally? Okay, acid normally, you put into dissolve it in water, right? Okay, put into the water. Okay. Then maybe, okay, you use a litmus paper, right? Okay, dip it in, then it turns color to red. Blue litmus paper turns red, right? Then what is the operational definition? Okay. Acid is what? Acid is a substance. Okay. Okay, dissolve in water. Meaning say when you put what you do, right? You want to explain. Let's say you put the substance into the beaker, okay, then put in some drops of the water. What you observe, what you do, you can explain in details. Up to you. Okay, then it dissolves in water. Okay, then turns what you observe. Okay, turns okay blue litmus paper to red. Okay. So this is what you observe. It can turn a blue litmus paper to red color. Shows that it is an acid. Like this. Or if another one example is using the pH meter, so it shows a pH value less than 7, for example, is an acid. Okay, no? So operational definition. So what you do and what you observe. Okay, that class. Anything you want to ask?
Teacher, can we write in point form?
Yeah.
The answer.
Full sentence, you can write in point form, is okay.
Okay.
And then you can elaborate a lot actually. This one in the SPM, we can see a lot of students, they write a very long answer. It's okay one, Marker will go to search for the keywords. Okay. Another one is variables, variables, and okay, variables. So for example, this example, what is a manipulated variable class? So manipulated variable is what? The metals, right? Lithium,
Type of metal.
type of alkali metals. Okay, you can list out all the metals used also can. Potassium and sodium metal. Okay, or type of metal. Okay, responding variable. We want to test what?
Reactivity of metal.
Okay, reactivity. Okay, reactivity of metal. Okay, with water, right? Water. Okay. Fixed variable. Size of alkali metals. Size. Okay. Okay. Next is the hypothesis. You need to know how to write the hypothesis. No matter what experiment is coming out, you will be asking the hypothesis. Okay, hypothesis. Okay, how to write the hypothesis? You need to relate these two, manipulated variable and then responding variable. Okay, so hypothesis. Okay, so in hypothesis, you need to mention the MV and RV. Okay. Okay, and remember direction. Mostly you need to mention about the direction of direction. Okay, direction. Okay, direction here normally, okay, you will use what? Okay, increase. Increase. Okay, decrease. Higher. Lower. Okay, more or okay. Now, okay, what is the manipulated variable is the type of metal, right? Okay, a type of alkali metals. Okay, so as going down, group one, one, okay, from lithium to sodium to potassium, for example. Now you have here three, right? So we list out all these three. Okay. So responding variable is the reactivity, right? So what happens to reactivity? Reactivity towards or with water is what? What happens to the reactivity class? So put in the direction. Higher, lower,
Higher.
or increase or decrease class? Okay,
Increase.
higher. Increase also can. Okay, higher. Okay, higher. So must be comparison. Okay, lebih tinggi reactivity dia. Okay, if I put lower, can or not? Class, can I write lower?
No.
Why cannot? Why cannot?
Because the reactivity is increase going across the group 1. Going down the group 1.
The group one. Okay. Yeah, theoretical is cannot lah, but under hypothesis, if you write down lower, it's still consider full marks. Still consider correct hypothesis. Okay, because this is the correct way, okay, or perfect way to write the hypothesis. But this hypothesis will be rejected one, rejected at the end. Rejected hypothesis, but it's still correct hypothesis. Understand? Meaning that if your techniques to answer to write your hypothesis like this, got direction, got MV, got RV, and direction. Although later on your hypothesis may be rejected, let's say it should be higher, but you write lower. But your hypothesis, you still can get full marks if you write the wrong direction here. Understand? Meaning that you can put any one. You put increase, decrease, or higher or lower, but it still can get full marks under hypothesis. Oh, okay. Another one, okay, this is one method with direction. Okay, number 2, second type is like, okay, can or cannot. Okay or not? Meaning that, let's say, I give an example. What example? Okay, for example, the example just now. Okay, sodium oxide and magnesium oxide is soluble in hydrochloric acid. Okay, hydrochloric acid. Okay. Then silicon oxide is soluble in sodium hydroxide. Okay. So meaning say this one is another one method to write the hypothesis also. Meaning that you see these two actually it is soluble, it is basic oxide, right? It is soluble in acid, no? Okay. If you want to mention egg in here also can. Okay, but insoluble in sodium hydroxide also can. Then silicon oxide is soluble in sodium hydroxide, but insoluble in hydrochloric acid. Like this. Meaning that you have two opposite condition like that. Okay, reverse condition like that. Also can consider a hypothesis also. Okay, or not? So basically, there are two methods here to write the hypothesis. Mostly is the method one, but sometimes in certain one you cannot use the direction. Sometimes you cannot see the direction. Okay, for example here, magnesium oxide, sodium oxide soluble in hydrochloric acid. Then you cannot write the direction, right? Cannot write increase, decrease, right? So you can use a can or cannot, like that. Also can becomes a hypothesis. Anything you want to ask us? Okay, so if no questions, okay, then we can move to the chapter 5. Okay, that's all I want to discuss on the paper 3. Yeah. Okay, so very simple one, very simple one. You just read over the experiment we have done. Now we go to paper 1 first. Okay, we go to paper 1. Okay, where we stop? Last week. Where we stop? Which page, class? Last week. Muka surat berapa? Anyone can let me know?
The objective one, Kak teacher.
Objective.
Wait, let me find. I think we stopped at page 69.
59, 69.
69.
Okay. Thank you. 69, 63. Yeah, right? Oh. Is this question?
No. Oh, sorry. It was page 70. 69 already discussed.
So this one also discussed already, huh?
No,
Ini sudah
that
kan?
one haven't, I think. No, that one haven't. 70 haven't.
B69, right? Ini habis kan?
Yeah, 69 dah habis.
Okay, thank you. Okay, now we look at this question, page 70. Okay, now diagram shows the arrangement for compound. Okay, so class, here remember, okay, you see like sodium, chloride, okay, one metal, non-metal, and then you see the positive, negative. So this is what? Ionic, ionic. Okay, so which of the following can react with chlorine to produce another compound which has different type of particles? Okay, so class, what is that means? This one is ionic, right? This one is ionic. So meaning that here, it wants a different type of particles. So another type of particles is what? Covalent. Okay, covalent. So meaning that you cannot choose the metal one, because covalent must be non-metal with non-metal, right? So which one is the non-metal here? Mana satu ialah bukan logam? If we want the covalent. Lithium, metal or not? So it's carbon. Carbon is non-metal, so 3 can. Lithium is a metal, right? Okay, so metal.
Yeah.
So it will be same type of particles. So don't choose lithium. No? Beryllium
Hydrogen.
also metal. This one also metal, so this one also don't choose. So hydrogen, non-metal. So non-metal with chlorine. Chlorine is non-metal also. So these two, 3 and 4. Okay, so 3 and 4. Because covalent is non-metal plus non-metal. Okay, so 3 and 4. Okay, next. Okay, ionic. Okay, if ionic, A, correct not? Betul kah? No,
No.
This one is
No one
sharing.
share. So it's
Sharing is
covalent.
covalent. Okay. Then how about this? Ionic or not?
Also share.
Share, but this one got charged. What is this class? Anyone know?
No.
How about others? Ini apa?
Is it hydroxide? I
Not
don't know.
hydroxide. This is the H3O plus, right? Okay. There are 3. So hydrosodium ions. It is under which one? Dative. Dative one. Okay. Relative bond, refer back. Okay, next. How about C? Share. Okay. So this one also share the electrons. So this one is covalent also. But the sharing is something like out of our syllabus already. Because the sharing one is slightly different. Okay, so not the ionic. So only one. Okay, so this one. The answer is D. Okay, next, covalent. Okay, what is mean by covalent bond? Which one is correct? Weak van der Waals between the non-metal atoms. Is this the correct definition?
No.
No. Okay, B. Bond formed when the metal ion transfer electrons to non-metal.
No, it's not metal ion to non-metal, non-metal atom to non-metal atom. That's ionic.
This one is ionic. Correct. This one is ionic. Okay, ionic. No. If transfer refer to ionic, transfer electrons. You see, when the non-metal atoms transfer electrons to non-metal atoms transfer
Not transfer,
non-metal.
they share. Covalent share, so not transfer.
Yeah, no transfer. So non-metal share electrons. Yes, remember, share electrons to achieve a stable electron arrangement. So D. Okay. Again, it's the same. This one. Same question. Okay. Same revision. Okay. Next. Which following are true for formation of covalent bond? Okay. 1, correct or not?
No, because that's ionic.
Between metal and non-metal. Okay, so this one is ionic now. So this one wrong. This one number 2.
Yes, because non-metal.
Okay, between non-metal and non-metal, correct. Sharing of electrons? Yes or no?
Yes.
Sharing of electrons. Ions are formed? Is it forming the ions for covalent?
No, it doesn't form ions.
Okay, yeah, no. It should form what? After they share the electrons. It should form what? What are formed? Or what is formed? Anyone? After they share the electrons, it won't form the ion, right? So it should form what? It should form, record down, it should form the molecules. Okay? It should form the molecules for covalent bond or covalent compound. That's why we say it cannot conduct electricity, right? Because it has molecules only. So 2 and 3. Okay? Now this, what is this?
What do you mean?
PQ2, PQ2, PQ2. So this one is a covalent, right?
Yeah, covalent.
But this one is P. Okay, so which one is represented by Q and P?
Q is 1 electron, so hydrogen.
So it's hydrogen. How about P?
P is 2, 6, so it's chlorine.
2, 6 is what?
Chlorine.
Is it chlorine?
There's only one. Wait. Sorry, I did it wrong. Sorry. It's oxygen.
So it should be oxygen, right? This one is 1 only, right? 1 is hydrogen, so Q P should be oxygen. Okay. P should be oxygen. Q should be hydrogen. Okay. Deal. Oh. Okay, boleh nggak ini? Can?
Boleh.
Okay, because almost 9:30, so we go to the structure. We do try to do one structure question tonight before 9:30. Yeah, okay. Where we stop? Oh, okay, yeah, here. Correct. Okay, now. Diagram shows a restructure for formation of ammonium ions. Ammonium ions. Okay, so class here. You see here. This one. Meaning that these two electrons is on by the nitrogen here. So meaning that this hydrogen ions don't have any. Okay, so what is this
Teacher,
bond called?
is that structure question?
Yeah,
Which page?
I think. Let me see. Last week we stopped at.
We stopped at. Oh yeah, I found it.
Correct, huh? You
Yeah.
look at the Putrajaya one. We continue.
Okay.
Yeah. Okay. So what is this bond called?
Covalent? I don't know. No.
It's under
No,
covalent.
it's dative, right?
Under covalent, it has another one is called dative. So dative bond, it has only two examples. One is hydrosonium, just now we mentioned already. Another one is this one, is the ammonium. Okay, dative bond. Okay, which the electrons is only contribute by one atoms only. Okay, so what is the electron arrangement for nitrogen atoms? So here you have to see the question carefully. Here the question wants you to mention about the atoms, not the ion. So nitrogen atoms. So how many atoms it should have? Okay, so I use the different colors. You see here, these hydrogen atoms. Oh, sorry, I need to put it smaller a bit. Okay. So meaning that class, this, let's say this hydrogen belongs to hydrogen, this hydrogen, right? Then this hydrogen also on one that contribute one for sharing. Okay, one of these satu ini. Then this hydrogen, this one, for example. So meaning that the other one belongs to N. So N how many? How many nitrogen? How many electrons it has? So meaning that it has 1, 2, 3, 4, 5. But this is a Lewis structure, right? Okay, so it has how many electrons for the nitrogen class? It has shell 1 on it. This is 5 already, right? So 5 is not possible first shell, right? So meaning that it should has first shell. First shell is 2 lor.
2 shell.
Yeah. Then second one is 5 lah. 1, 2, 3, 4, 5. So it's 2, 5 lor. Okay then. Any question? Can follow. How about the others? You must understand. Can? So it's 2, 5. Now type of bond. We mentioned already is what? Dative, dative bond. Dative bond. Okay, now next. Okay, X and Y. X and Y. Okay, so to form the compound P. Okay, so easier, we write out the electron arrangement for X. What is the electron arrangement?
281.
Okay, 281. Huh? So it's a metal. How about Y? Y atom?
26.
26. 26 is non-metal. Metal, non-metal. So you form the
This ionic.
yeah. Okay, so chemical equation for the reaction. Okay, so X is what? 1, so it's group 1, right?
Potassium.
Potassium. No, 281. 281 is sodium, actually.
Sodium.
Sodium. So sodium is a metal, right? So it's an X, right? It's a metal. Sodium react with what? This one is 6, 26. 26 is what?
Oxygen.
Oxygen. So oxygen is O2, right?
Y2.
Sorry, yeah, should be Y2. But if you write O2 is correct also, because this one is O, right? Okay. Then what is the product? If these two combine as Y, what is the formula?
XY2. XY.
XY?
X2Y.
S2Y should be X2Y, yeah? Okay, why X2Y? Because this one lost 1 electrons to here, but this one needs 2, right? This one achieve octet, but this one 27 only. Y atoms 27, Y ions 27 still not achieve octet. So meaning that you have to times 2 here. 2x. So meaning that next will be X2Y. So it's not balanced yet. So this one times 2. Okay, so this one times 4. Okay, how class? This one dative bond, it also can call coordinate bond also can. Okay. Next, okay. Calculate the mass of the compound P formed if 0.0125 mole of gas Y used in the reaction. So P is this one. So what is the mass? Okay, if Y, gas Y is 0.0125 mole. Y 0.0125 mole. Okay, so what is the mass? Okay, how? Okay, mole already find, so no need to find. Step 1 normally you need to find the mole, but here already given, so no need to find. So directly step 2, mole ratio. Mole ratio, this one is 1 to 2. Okay, so 1 to 2. Then if 0.0125, then what is the mole for this? X to Y. 1, 2, double, right? So how many more for X to Y? Plus? Yeah, what is the mole class? This one 1 to 2 is 0.0125. Double, right? Times 2, 0.025. Okay? Then you have the mole already times the molar mass. X to Y, X to Y. Is given or not? X to Y. Yeah, X to Y. So total up X to Y, molar mass, so 23 times 2 plus 16. Okay, so 46, 16. So it's 62, right? 62, yeah. So it's 1.55 gram. Okay, 1.55 gram. Okay. Then, okay, in another reaction, element carbon react with Y. Okay, Y here is O, YO, to form the compound Q, which exists as a gas compared to compound P that exists as a solid. Explain the difference in the state of matter. Okay, in the room condition. Okay, class. If states of matter is referred to what, class? One is this as gas, another one is this as solid. Okay, this one refer to what? Melting and boiling point, right? Okay. Melting and boiling point. Okay. So Q exists as gas at room condition. Why it is exists as gas? Meaning that the melting point, boiling point is very high or low, class, if gas. Boiling point is boiling point very high or low, class? Yeah, class? High or low? Boiling point is high or low, class? Hello? Hello? Can hear my voice or not?
Yes.
Yeah. If it exists as gas at room condition, meaning that the boiling point is very high or low? Low lah, huh? Low. Okay, boiling point very low. Q lah. Q is what? Covalent, right? Covalent. Why boiling point is very low, class? It had what? You need to explain, no? Why boiling point is very low? Refer to the knots, huh? What is the force? What is the force? Weak Van der Waals force. Okay, weak Van der Waals force. Yes. Okay. Then this one, compound P in solid, meaning that the boiling point, this one is melting point is very high. No? Why? What force it is for compound P? For ionic compound, what force? Boiling point, melting point is very high. No? Okay, melting point very high. Okay, why?
Electrostatic force.
Strong electrostatic. Okay, force. This one is weak Van der Waals. Okay. Okay. So compound B has strong electrostatic force. Strong. Okay. This one compound P, Q. This one weak Van der Waals force. Okay. So more heat energy, more heat energy needed to overcome the force in the P, the electrostatic force. Okay, then Q. This one less energy, less heat energy. Okay. Better you put in the strong and weak now, these two. Okay, so you can record now. Okay. So class, I think we stop here for tonight's lesson. Okay, tonight. So read the experiment. We have done the experiment. Okay, so you just read over. Okay. Any question you can ask in the group. Okay. So thank you, class.
Thank you, teacher. Bye bye.
Bye. Good night.